this universe, dark matter is invisible to our eyes. Dark matter cannot be observed too because it can't emit anything. Then how did scientists found this dark matter? Is dark energy and dark matter the same? In this universe, there is 67% of dark energy and then there is 28% of dark matter, and the remaining 5% of universe is the regular matter. From being a part of this planet Earth, for the planet Earth to revolve around the solar system, for the sun to revolve in the galaxy or galaxy cluster, gravity acts as a glue for all these things to happen. Rather than finding that unknown, to derive at there is something unknown is a much difficult one. Likewise, gravity has helped to know better about these dark stuffs. Likewise, a group of many galaxies is known as galaxy cluster. There may be some force of gravity between them for being in a group. There are many galaxy clusters like these. In 1930, Fritz Zwicky researched about a galaxy cluster called Coma Galaxy Cluster. He calculated about the mass, luminosity and distance of the cluster, but he found that to have a movement like this, the mass should be 400 times more than the calculated one. He was puzzled about why this mismatch is occurring, so he researched a lot and told that there is something that is driving these clusters that we couldn't see. And he coined that unknown thing as dark matter. He named it this way is because there is something that is unknown to human eyes. Dark matter was considered as yet another hypothesis and was not much recognized at that time. Few other hypotheses on dark matter too have been said further. But in 1970s, Vera Rubins of USA have been researching on galaxies and said there should be more mass than the ones we see. After this event, dark matter has become a serious thing. When the galaxies rotate towards its center, we may think the speed of rotation would be slower at arms and faster at the center. But it is found that everything in galaxy rotates at equal speed. For this to rotate in equal speed, where did this get its extra force? They predicted that this matter alone is not enough for this equal speed of rotation. There should be something else. This is only an hypothesis, but how can you be so sure on telling this? From certain other things, researchers have confirmed that dark matter is available. The specialty of astrophysics is we can tell about an unknown object by its impact. For example, by calculating the impact of the sun on Earth, a calendar is being created and used by all of us. This was created even before knowing the fission and fusion reaction happening in the sun. For example, if an object drops, it can be anything like a stick, apple, stone, etc. But by knowing its velocity and gravity, we can measure the mass of the object. Likewise, dark matter can also be calculated using some measurements. Even though it has been researched about in 1930s and 1970s, in 2007, a galaxy cluster like Coma named Bullet Galaxy Cluster was found. Using Chandra X-ray telescope, it was found that there is an extra matter other than mass. Dark matter can't emit anything is because of the phenomenon WIM. That is, weakly interactive massive particle. This dark matter doesn't interact with anything. It is believed that it could not interact with an atom too. But to strongly prove that about dark matter, we should take a note on its gravity. Yes, dark matter has the property of gravity. Space-time warp, which looks similar to a blanket. Earth makes a curve in this space-time. Bigger stars like Sun make a largest curve in space-time. Depending on the mass, the curvature increases or decreases. A black hole makes the largest curve in space-time. Likewise, dark matter also has the capacity to make curve in space-time because it has mass. Using gravitational lensing, we have confirmed about the dark matter. Gravitational lensing is similar to light traveling through lens by making a curve. Likewise, a light from any part of the universe makes a curve while traveling through objects like galaxies and reaches. For example, consider a star's light traveling through the galaxy by making a curve and reaching us. The object of hindcare influences the amount of curvature of light. On seeing the shadow, we can guess the object of hindcare at the light source. Using gravitational lensing, we can tell about the unknown dark matter. For example, you are sitting under a tree. You look up and see there are no branches and leaves, but you get shade. This means there is something that hinders light source to provide shade. So this is how dark matter is confirmed by using gravitational lensing. This dark matter is filled up all in the whole universe. Dark matter can be around all of us too. Many experiments have been done to clear this about. The first thing is direct detecting. Many detectors have been installed in undisturbed areas of Earth. Using detectors and LZ experiments, they are trying to find dark matter. Also using Fermi Gamma Ray Telescope, we are trying to find dark matter in space. Using Particle Collider too, experiments are being done to find dark matter. Einstein too had already hinted on this dark matter. While the detecting process of dark matter, Jupiter was chosen for the research because of its huge size. By using Fermi telescopes for 12 years of data have been collected and researched and found gamma rays on that research, but nothing about dark matter was found from that research. Scientists felt the difficulty to know about dark matter in Earth and Jupiter, so they shifted their focus to exoplanets. We can easily know about the interactions of dark matter in exoplanets by using James Webb telescopes that we send out to space. In 1917, Einstein said that empty space is not nothing and it has amazing properties. So he used cosmological constant in one of his equations. This cosmological constant could be the dark matter is speculated by him. This empty space can create energy by itself, that is dark energy. It creates a temporary virtual particle and destroys it parallelly at the very same time. This is why we can't observe this process. The outcome of this process generates energy that makes the universe expand. That energy is dark energy, which is a topic for another video.